All right. Hi, everyone. Oh, wow. I was going to ask if you can hear me, but I can hear myself echoing off the back wall, so I assume you guys can hear me. My name is Mark Stantragier. I'm the Director of Analytics. If you're not expecting to hear about Hadoop and Tableau, you're in the wrong place. You may want to quickly run to somewhere else. But I am going to be talking about Hadoop. So the agenda for today. I'm going to divide this talk into two separate pieces, obviously connected. The first third or so of the time we've got together, I'm going to talk through the business proposition for going to Hadoop. Why my company, and I'll explain a little bit more about who I am and who I work for in a minute, but why we went to a Hadoop platform, why we made that leap, whether it was a good idea or not. And then the second two-thirds, I'm going to talk about some of the problems we faced and how we overcame them. Now, this isn't going to cover every possible problem you could face. This is probably only a small fraction of the ones that we face, but it's the stuff that we really, really, really wish we'd known about 2 years ago. It would have made the next 2 years much happier for myself and engineers and analysts around me. So let me, first of all, for those of you who don't know Ebates, sometimes I say it's the best kept secret brand. A lot of you in the room will know exactly who we are. Everyone else won't have a clue. We're a cashback online site. So you sign up for an Ebates membership account, you go shopping online to major US retailers, Macy's, Amazon, Best Buy, whoever you buy from. We work with most big merchants as well as a lot of small ones, up to 2,000. And we will give you cash back on whatever you spend, usually a percentage. So if you spend $100 at Amazon, you get $1 back. Doesn't sound like a lot, quickly adds up. We've seriously got people with thousands of dollars sitting in their accounts, or they've earned. We actually have tens of millions of members worldwide. We have sites in Canada, Korea, Singapore, China, Japan. We represent, this figure is actually a little bit old, something like 7%, give or take, of all e-commerce transactions in the US will go through us, right? So that makes us pretty big. We are a subsidiary of Rakuten. For those of you that don't know Rakuten is kind of like the Amazon in Japan. It's like a whole infrastructure out there. They bought us in 2015 for $1 billion in cash, which was nice. And just a fun little stat I always like to put out there. Does this really work? Yeah. So far, we've paid out $725 million. That's over the last 10 years or so in cash back that we've given back to people in rebates. So pretty big scale. Who am I? I'm the Director of Analytics for Ebates. That means I sort of have three different hats I wear. I'm the product manager for the enterprise data warehouse. So I set the data warehouse direction, including setting the priorities for the data engineering team that support that. I also oversee BI products, which is primarily Tableau, but if we do other bits and pieces, I also oversee that. And I run a team of analysts and data scientists who kind of work within the organizational groups, kind of like a matrix model, but they sort of report into me as well. And I'm also responsible for training on BI reporting infrastructure for the whole company. All right, enough about me. I'm going to take you back. We're talking about 3 years ago at this point. We had a problem, and it's probably not a problem that's going to sound too dissimilar to a number of you, which is we were on an old legacy database system. I won't mention it by name unless I forget to not mention it by name. Take your pick. But you know, it was a single server proprietary system being put in place for 8 years at that point, and the thing was dying, right? It couldn't handle our data volumes anymore. We had ETL processes running 26 hours to try and get the data back. Not good. It was completely incapable of the flexibility we needed to absorb new types of especially unstructured data, but even just getting the new tables from our production systems was starting to become a problem. And we were facing, we just run out of capacity. We couldn't buy a bigger machine, even if we wanted to. So we were facing the prospect of, well, we're going to have to start splitting into multiple machines. We've got data silos. We're going to have to get into data blending. We're going to have to put a whole infrastructure in place across this just because this machine can't do what we want it to do anymore. Okay? So the product manager in me came out, and I went to our exec team, our power users, other business users around the company, and said, okay, we know that this system has got problems, but what do you guys really want? And immediately regretted asking that question because, of course, it turns out they want lightning-fast reporting, they want drag-and-drop analytics, they want to be able to scale this thing horizontally and cheaply for the next decade. They want fast ETL. You know, we want all of our business reporting by 9 a.m. the following morning at the latest. And if you can give us real time, that'd be awesome. And they didn't want any data siloing. And this is the bit that was like, ooh. And then I was like, okay. But that's good because that means my analytics team, everyone else is going to be more productive over the long term. But okay, now I've got to figure out how to do that. Okay. They also wanted to be able to drill into the data at whatever level they wanted. I have the dubious distinction of working for a company where half of the exec team came from a data background. So it's probably relatively dissimilar, but half of my exec team come out of sort of email, ESP space, data append space. So they're like, no, we want everything super granular. I want to be able to query anything at any time. Okay, all right. So it's a tough list. So they're looking for next-day latency. They want to be able to do ad hoc SQL querying through a straightforward SQL interface like they've always done it, or at least close to. They want to be able to do data visualization, including drag-and-drop analytics, right? So basically Tableau desktop with drag-and-drop analytics. They also want to be able to immediately control third-party systems off the data warehouse. We'll come back to that. But imagine we actually control the emails that are sent out to our members directly from the data warehouse. Why did they want to do that? Well, that means that all the information we have available in the data warehouse can immediately be used to target those emails. Makes perfect sense. Not super easy, right? So pretty tough list of things to try and get to. We went away, myself, the head of the engineering team I work with, and we looked at our options. You know, we could have gone in a Teradata, and bear in mind this is 3 years ago, so the landscape was even rockier back then. We could have gone Teradata. That would have been a relatively obvious way for us to go, sort of mirror the relational data warehouse, the Snowflake schema that we had onto Teradata and just try to sort of figure out the other bits around it. The cost was just beyond us at that point. By the time we'd actually gone through all of this list of functional needs, the only way that we could figure out to do it was on a Hadoop platform at that point, right? There was nothing else that wasn't going to constrain us in a way that would have blocked some of these capabilities, right? Another guiding light that I imposed on this, just in case our job wasn't hard enough, is that I wanted to make sure that I could use the best of breed third-party products within my infrastructure, right? So I wanted to make sure I could use Tableau Desktop as the visualization tool on top of whatever we did. I didn't want to get locked into a proprietary visualization tool. I wanted to be able to plug whatever sort of messaging incoming feed system into this system and make it work. Kafka, if you don't know what Kafka is, just assume that it's a really good messaging technology. If that gets replaced 2 years from now, I want to just be able to swap out that component without completely destroying my data warehouse and starting again, right? So I didn't want to get onto a monolithic all-in stack where I'm then locked in and I can't swap pieces out as needed, okay? We made the task relatively tough for ourselves, and the only way we could think that we could possibly achieve all of this, even in theory, was to go to Hadoop, right? To use distributed cluster, horizontally expandable, and in an open way where we could basically, you know, put whatever scripting language we want on top of Linux boxes and do this more complex, more detailed, more advanced work using those data sets. So that is what we set out to do. So what did we actually implement? I'm going to do a fun little diagram here. So I think, actually, let me pause just 1 second. I meant to ask this up front. Raise your hand if you're currently working with a production Hadoop deployment. Okay. How about add people who have sort of like a POC that's kind of up and running but maybe isn't production yet? Okay, so most people in the room at least have got something kind of working, at least to some extent. So this concept's going to be familiar to most people. The first thing we want to do is form a data lake. And when we talk about a data lake, this is just read in from production data sources and do very little in the way of transformation, any kind of management, just get the data onto the systems. And for us, we're pulling from production databases all around the company. We're bringing in something like 700 tables, I think, at this point, from various different systems around the company. We're also getting clickstream data from various homegrown and third-party applications that we're bringing in. Again, that's your unstructured kind of data. We've got a lot of sort of textual data in there. We don't do a whole lot with social at this point, but we do have some in there. Third-party APIs, right? So again, thinking about the email vendors, these guys provide APIs where you can see which emails were clicked on, which emails were opened. You can pull that back as a production data set. So we're doing that with a number of vendors through APIs. And we actually do have a few flat files where literally they're sitting on a server and someone tweaks it, saves it, and we'll bring that in and use that as a data set, right? And all of that just goes into our data lake. What we then do is, and this is still within the Hadoop, so the data lake is on Hadoop, it's within HDFS. What we then do is we have ETL scripts running on the Hadoop platform that take the data from that data lake and produce much more usable tables out of it, or data sets out of it. It's not always tables. So we have effectively an internal ETL process. I'm not going to go too much into this technology right now, but we're primarily using Python and Scala to do that, mainly using Spark. We then have at-scale that sits on top. If you don't know what at-scale is, it's a great little third-party product. Primarily for us, it is an optimization tool. If you are interested in that, I'm actually doing a talk with the at-scale guys tomorrow, and they have a booth downstairs on the display floor. Do check them out. It is a critical piece of our infrastructure. And then we actually start exposing our data into the endpoints, right? So we have Tableau server, we have Tableau desktop, connected from at-scale, also connected from the warehouse, and of course, just directly connected from the data lake, which is nice because, you know, sometimes you just want to bring in relatively raw data and just double check it. Maybe you don't want to spend a whole lot of time getting it up into the data warehouse layer and producing ETL. Not a problem. We can still just connect to it directly. It just makes the SQL a bit more complicated. We also I sort of highlighted that because we are at a Tableau conference. It seemed important. But just to kind of round the picture out, all the other stuff I talked about, feeding data to ESPs, other vendors, we feed a lot of data back to our production servers, things like that. So those all come in, and we actually feed those from both the data warehouse and the data lake as well. So overall, and all of this is within HDFS, it's all on the same data nodes. So it's all immediately accessible, right? Hence, no siloing. And this was the plan, and this is actually what we did. So I don't know if this is actually unique. I know it's relatively rare. I don't have to worry about data blending. I don't have to worry about data siloing because I don't have any data silos. So there's a whole lot of great innovation coming out that, fortunately, I don't even have to consider or worry about, which is nice. All on HDFS. So just briefly to give you an overview, right? In terms of component pieces, it was a deliberate tactic for us to use multiple different pieces so that we weren't tied into one monolithic technology stack, and we made a big deal of that. Now, the end result of that is you end up managing a lot of different pieces of technology to do different things. Some people think that's a huge pain. It was actually a desirable result for us, given our experience. So I'm not going to read everything, but you can kind of take the key components here. We use a lot of the main infrastructure pieces, Spark, Python, Scala. We use Impala a lot. We use Python a lot. We found that Scala is important at some points if you need very fast movement across the networks. We have got R plugged in there as well for our data scientists. It also means that we're keeping an eye on things. So, for example, those of you who have heard of Hadoop at this point, we don't actually believe it's production ready just yet. But we did try it as an alternative mechanism to speed up some of our operations, right? So we can just plug and play with these things as they come up. We're looking at Drill right now to see if that's got any use cases that we may want to consider. So a lot of components. Now that means that for those of you who are just starting in on this or haven't even really got into this yet, that can be really intimidating. It does mean that you've got to go down a laundry list of stuff if you want to follow that approach. So what I would point out is in our initial, we're now 3 years down. If we jump back 2 years, we had HDFS, we had Spark, we had Python, we had Tableau, and we had Impala, and that's it, right? So, and Python, if you've got data engineers, they probably know that. Spark was the only one that we had a real learning curve on, within my organization at least. And they now love it, but that was a learning curve. So what does this timeline look like? What does this timeline look like? Again, I'm not going to read it. You guys can read. But it was effectively from where we sort of started going with POC, does this make sense? Are we making the business case here in sort of early 2014? By the end of the year, 2017, we were completely off any type of relational database, right, for any BI needs. So today and for approaching a year now, we have been all of our data warehousing, all of our analytics is done directly on top of Hadoop, right? There's definitely some optimizations. There's definitely some other bits and pieces around the sides, but we've been all on Hadoop. If you read through this, you'll notice we're now on cluster number 3. So my tech team really likes to own their technology. We are not in the cloud. And that's going to feel a little bit discordant to a lot of people in the room as well. We did the math. We figured it was significantly cheaper to buy and manage the stuff ourselves rather than putting it in the cloud. And you have to do the math for yourselves. We just redid it recently and still come to the same conclusion. It does mean that you need support from your tech and operations teams or however you're organized to be able to do that though, right? So if your tech team doesn't know Hadoop, hasn't got the resources to do that, then that may not be an option. The other disadvantage is we've gone through 3 clusters. So we've tried 3 different types of hardware, getting more sophisticated about our buy-in technique each time. Now that hardware hasn't gone to waste though. We now have a production cluster. We now have a backup cluster, which is the phase 2 cluster, and we now have a QA and dev cluster, which was our phase 1 cluster, right? So we've just sort of repurposed them down the production level line. Our ops team is actually pretty happy still with the cost we're getting out of it. So just be aware that you may not nail this first time. And I wish I had set more the expectation that that could be the case, I would say, earlier in the process. But we now got to the point, this is up, it's running. We don't actually have any major issues other than just trying to keep up with the demand. I mean, for those of you who've been in BI for a while, I'm sure you've got the same experience as me, which is the minute you supply something, people are like, this is awesome. Can I have these 3 things next? It's like, sure, all right. And you keep on going. But for me, compared to, oh, this is broken, I can't get what I need, your runtimes are horrible, like, why am I waiting for stuff? People coming to me and proactively saying, no, this is great, but I need more, I'm fine with. I'll take those conversations all day and figure out the priorities with them. So did we, just to sort of go back to the original list of things that we were meant to be doing, did we do that? So do we have next day latency and SLAs? Yes, we do. All of our key reporting is done by 9 a.m. the following business day with a 90% plus reliability rate. Where we miss occasionally, it's usually by 2 minutes, 3 minutes. We have ad hoc SQL querying. That's no problem to us because we can use the Hue interface on top of Impala. Tableau is linked in both in the server and in the desktop. I have dozens of desktop users, hundreds of server users, all hitting this thing. It works fine. Drag and drop analytics. We are controlling outgoing communications. Actually, at this point, we control push notifications as well as emails, which wasn't really as big a thing when we set out. But we do that kind of customer communication piece. And we're also now doing things like feeding data back into production systems. So without going into this too much, I can deal with this in Q&A if you're interested. Because we do data science on this platform as well, we can do data science using the existing data within the same Hadoop cluster and then pipe it back to our production databases and our production applications without introducing any infrastructure that doesn't already exist, which is kind of cool. So for example, if you're an Ebates member, today, which emails you receive will be decided by a chunk of data science, like a recommendation algorithm we put in place. In the near future, that will also control your on-site experience, and we didn't have to replicate the model. There's no real additional infrastructure. We would have done it 6 months ago. We just had to wait for the front-end application team to get the functionality there. The other thing we found is we could just tack on a ton of things that we hadn't even taken into account as what we wanted to do for the first initial implementation. So we've now got fraud detection algorithms running on top of these data sets. We're now bringing in click streams that we didn't know would exist. We're bringing in marketing data from third-party APIs that weren't even around when we set out. So we've just been able to bolt these things on as we went along. And one of the really interesting ones is we were actually able to put much better and stronger process monitoring and control in place than we were on the old proprietary system, which sounds odd and counterintuitive. And I'm going to talk about that more as an example. But that, for me, as the owner of this product, being able to see what's running, when's it running, how long's it taking, and is it failing, was like a huge win to be able to convince people of the value of this platform and the progress we were making. So yes, we accomplished what we said we were going to, and a lot of other stuff, and people are pretty happy. Was it easy? No, it was a killer. Okay, anyone that tells you this is going to be simple, like, it's that classic thing, right? Like, don't believe them. Like, it's definitely better now than if you were trying to do this 3 years ago. There's more resources. I have a very good engineering team. I've got a supportive ops team. I own BI as a whole, and even so, this was hard, right? So if anyone thinks that this is going to be easy, if you're talking to a vendor that says, oh yeah, we'll have you up and running and it will do everything in a day, like, take that with a big grain of salt. It took us 3 years to get to this point, and there was a lot of pain along the way. So I thought, I could share some of the things that were a little bit painful, help you guys maybe head off some things that we found out the hard way. Let's start with speed, because people want reports fast. I mean, we sat through a keynote this morning that was like, 50% about getting faster. Hadoop is not necessarily fast. I know from talking maybe to some of you in the room, definitely to other people over the last couple of years, that this is a major problem, right? Trying to get these things to run fast is not easy. And it's especially not easy if you do what we did, which is take your relational Starflake schema from your legacy data warehouse and put that on Hadoop and think, well, I've got more power, this is going to be awesome, and then it runs as fast, in our case, slightly slower. And you're like, what just happened? I've got 10 times the machine power out there, right? Don't do that. It's really bad. And if you have done that, I'm sorry to tell you, it may not be worth trying to fight through tweaking it. You need to sort of take a step back. Why is that not a good idea? Well, you're now working with Hadoop. Typically, if you're using Hadoop, you're going to be on multiple different machines, right? That's the benefit it gives you. You've got a cluster of machines out there. The problem is your joins, right? These machines can crunch data fast. The problem with a join is that you've got to move the data between the machines. At some point, you're going to have to move the data between machines. Distinct counts, same kind of problem. To actually work out what distinct values you've got, at some point, you've got to consolidate all of this data into one place so it can figure out how to do that, right? Although there's some cool innovations around that. But anything that hits those network connections, anywhere where you've got to move all of the data into one place, or where you're swapping lots of data across the network, is going to slow you down. And joins are the major place where that was happening for us. And it was killing us. The good news is we found this out, and there are a couple of ways to try and approach it, right? So sometimes you can't avoid joins. Sometimes it doesn't make sense to if you're just trying to, does this data even line up? Like, have I got the data points that I'm expecting to get, right? You may want to do it. So there are some, one thing we found, we use Impala as our main SQL interface. Impala has, I would say, a relatively well-hidden secret. Some of you may know about this. It took us months to find it. Impala has what it calls query hints, which allow you to tell Impala how to execute the query, which means you can look at it and can see how it's executing it. And if you understand enough about your data tables, you can force it to execute in different ways, doing things like, don't start with the really big table and move all of that data over everywhere. Start with this teeny weeny little table that only has 1,000 rows, and if you need to move data, move that, not my billion row table that you're joining to, right? It doesn't do it often anymore. It does still do it every now and then. You can also get very clever with this, and you can actually tell it how to move or what exact type of data movement to do on any given individual join. Is it worth tweaking to this degree? Well, it can be. We had one query in particular I worked on where we cut the processing time by somewhere around 80% by putting a query hint in place, right? Just something about it, just Impala couldn't figure out how to deal with this query. It wasn't even that complicated. I never figured out why it was having such a hard time with it. Putting the query hints in, 80% time reduction. It can make a huge difference. Are you always going to get that? No. No, most of the time, you're tweaking a little bit, bringing down the time a little bit, but it can be really helpful. It's definitely worth knowing it's out there. The other thing we found, especially in ETL processes where you're using Spark, at a certain point for our big ETL processes, we found that we needed to move to Scala instead of Python. Why? Because Scala is definitely more complicated. There's no getting around that. It allows you finer grain control, and it has less overhead in terms of memory use. So you can, if you're sophisticated enough with it, you can materially change your runtime. We took a process that was running using Spark with Python, moved it to the same Spark, but with Scala, and chopped the runtime of the job from 3 hours to 20 minutes, right? Again, that's the extreme, but you do see these differential behaviors, and they're well worth having. The big one, right? And going back to the Snowflake schema, and don't throw anything at me if we've got relational folks in the room, denormalize everything that makes sense to possibly denormalize, right? This is Hadoop. You don't want to move data across the networks unless you can, but it is fine with big files, processing big files and aggregating them. So our fact tables today are hundreds of columns wide, billions of rows long. We have strings embedded in there. We have arrays embedded in there. Just big tables, hundreds of columns, and it is so much happier. It's so much happier. It will definitely work way better with a huge table than having even a single join in there. If you come from a relational background, if you're trying to work with relationally focused DBAs, this will give them minor fits. And they'll say things like, but what about the storage space? What about well, Storage is cheap. No indexes anyway. Don't worry about that. And you'll just get massively better performance from these things, okay? And what does that actually look like in practice? If you haven't tried doing this, there is a learning curve to it. I mean, the simple answer is, just do all of your lookups and write it into the row at that time. The tricky question, if you haven't already realized, is how do I deal with updates on my dimension values, right? Yes, that is a pain. We found at least that it was worth dealing with that pain and effectively rewriting all the historical files as needed to get rid of the joins. And I can talk more about that if people are interested, but it was night and day performance for us. I would rather take a big backward-looking update job once every 3 months than have consistently 20-minute run times on something that I can now run in less than a minute. It's just me, but it seems like a fair trade. Another thing, and this is probably of the things I wish I'd known, this may be number one. We found that we were starting to deploy all of these cool reports. We had a ton of data. People were starting to use the system, and it was grinding to a halt. And we were like, okay, that's not good. We don't want this to grind to a halt. What's going wrong? So the first thing we did is we went into the cluster analytics, and we said, have we got enough memory? Have we got enough CPU? Yeah, we've got plenty. We're using like half capacity on both. We've got plenty of overhead. So why is this thing slowing down? Took us a little while, but we worked out that the reason it was slowing down is it couldn't get the data off the disks fast enough. So we just had machine processing power sitting idle. It couldn't get the data in to process fast enough to actually get the results back. And of course, the more writes you're doing and the more reads you're doing, the more your I/O situation collapses in on itself and you've got a bigger problem. There are a couple of things you can do about that. One is the extreme move to basically change your hardware, right? To realign your hardware so you have more disk capacity for the CPU and memory capacity that you're using. We did actually do that in our third cluster. We tuned that. But that's a pretty extreme option. The thing I would really recommend doing is use Parquet. Now, I don't want to go into a detailed description of Parquet because it's post-lunch and everyone will fall asleep. Put it this way, Parquet, if you don't know what it is, it's a way of storing files that's a lot smarter when you're trying to do these kind of big data pulls, especially where you've got wide tables, right? It stores data in a way that your columns are sort of separable. So if you've got a 200-column table and you only need 3 columns, it will only retrieve the data it needs for those 3 columns, right? Cutting down your data retrieval by 98% or whatever that math is, okay? It is, again, night and day. The only downside to it is if you actually do select stars a lot, it is a little bit slower to return a select star because it's got to find out where all those columns are. But for most normal business cases, especially where you've got some degree of tuning on the queries, it's lightning fast in comparison. You do also get the benefit that it allows for better file compression, which again, I'm not going to go into. But effectively what it does is it significantly reduces the footprint on your disks, and it allows you to get much faster I/O for the data you need. Meaning, we switched to Parquet, and all of a sudden, we had the other problem, which is we could get the data off the disk plenty fast enough, and now we were hitting 100% on our CPU and memory, right? You trade off, but I mean, the reports, all of our reporting and processes sped up significantly, so it seemed like a reasonable trade. So if you haven't yet committed to a file format, if you've got the option, go to Parquet. It makes a huge difference. Huge difference. All right, I'm going to keep going. Here's another thing we wish we'd realized sooner. It's actually, in some ways, the most straightforward one to fix. Hadoop doesn't love small files, okay? It'll work with them. It doesn't like working with them. And the reason is fairly straightforward. Imagine that you have a file, right? Say, it's a pretty big file. Say it's a couple of gigs file, right? it's got quite a lot of data in there, and you want to query the data that's in that file. Okay, so what actually happens when you execute your SQL or you use Python to call that data set or whatever is it has to open that file up, pull the data, and when it's done with it, it's going to close that file. Okay? Now, the trick is in that opening and closing. If you're dealing with one big file, opening and closing the file is insignificant, it's meaningless time. If instead of having, that 2 GB file, you have 1 million files, each with a couple of thousand K, all of a sudden that overhead in terms of opening and closing the files kills you. And what you'll see, and what we saw is jobs that were doing exactly the same thing, just on incremental data, exponentially increasing in runtime. Because the overhead from all of these little files was just adding up to the point where it was overwhelming the time that it actually took to do the data processing. So the data processing was still moving really fast, but all of this system I/O overhead in terms of opening and closing the files was killing our processing time. This is particularly bad if you're bringing in sort of like micro batches, say from like the way we do things. We've got certain APIs that we call every 5 minutes to get the incremental data, right? Because we want close to real-time data. It's not quite real-time, and it's not in like a stream, it's in micro batches. Well, if you're pulling a file every 5 minutes, 24 hours a day, right, for a couple of years, all of a sudden you've got quite a few files in that directory, right? And they add up, especially if you're combining multiple different streams into one directory, which is what we were doing. So what did we do about that? Well, we did this completely backwards, actually. So the first thing we did is we thought, okay, well, where we know there is this problem, what we can do is we can write a script that goes through, grabs all these little files, compresses all of the data into one new big file, and deletes all the small files. Yep, that definitely works. Makes a huge incremental improvement, right? And then you've got to stay on top of doing that. So that is now a scheduled process for us where certain directories get effectively consolidated on a periodic basis. Then we realized, well, that's great, but we don't know where the problems are. So now what we need to do is we need to write a script that runs over our entire HDFS directory structure and identifies the directories that have a lot of files and where the average file size is smaller than we want it to be, right? Because we'd come up with a way to fix the small file problem, but then we needed the way to actually find the directories that were causing the problem in the first place. So we obviously should have done those the other way around, but you live and learn. Like I mentioned, watch for any kind of streaming or micro-batch applications on this. The ones that were really killing us were Flume. For those of you that don't know what Flume is, it's just a way of sort of passing these micro-batches in. Where our Flume directories were generating a lot of teeny little files, killing our processing times. And because I'm an analyst at heart, what we did in that sort of, the job we wrote that scans through the HDFS directories is it will then actually log the directory, the file, the number of files, the average file size into a data table, which we then use Impala to query and put it back into Tableau as a visualization. So I have a visualization that gives me, for every directory on the cluster, the number of files and the average file size. That's what you're looking at right now. Obviously, there's the directory names over on the left. The size of the bar indicates the number of files. The color indicates the size of the files, right? Deep red, that's a problem. We need to go in and fix it. By the way, this is the before slide. In case you think I'm like telling you to do things and then just totally not doing them myself. This was the lead up to a big consolidation project. The other thing that, but the greens, right, the dark green, the light green, you got a lot of files in there. Well, sometimes, if you've got a lot of files, but they're all a good size, that's just a heavy data set, right? I mean, it isn't, it's not going to be quick to process. If you've got 100 billion rows in there, it's going to take a little while to process, right? But what the green indicates is that at least it is held in such a way that we're not introducing unnecessary overhead that we could get rid of, right? So actually, I think that one that I've got highlighted with the arrow there, we actually, because that was historical data as well, we actually ended up hard partitioning that into other directory stretches to try and solve that problem, because it was still really slow. But haven't got time for that. The other big one, and this is for the people who are maybe less on the engineering side, maybe more on the product side, analytics side of things. So this is my baby. I wanted a way to see what was running on the cluster in a way that made sense for me to run our entire Hadoop cluster as a product, right? What do I mean by that? Well, if you go into, we use Cloudera, you go into Cloudera Manager and you get a lot of great stuff. So I'm not putting the Cloudera infrastructure down at all. You can see how much memory are my services taking, where have I got problems, what are my disks doing, what's my peak, min, max capacity, what's my average. Okay, there's a lot of statistics in there. What it does not allow you to do, at least not easily, at least I don't think it does today, and it definitely didn't when we started on this, is actually understand what this process is, what it's running, what its business purpose is, right? And for me, that's critical. I need to know, application 112487 failed. Okay, well, I can get an alert for that from Cloudera. That doesn't tell me what that was, right? So then someone's got to go back and figure out what that application was and whether it's important to rerun it, whether it'll catch itself up, whether it's, whether we should tell someone that it's failed. Because we've got a lot of redundancy built in at this point, so a lot of failures we can ignore. We do still get failures, that's worth pointing out. So what I wanted was a way to be able to watch what was happening on the cluster, and in particular, when we kick off scheduled jobs, we've got a cron file, triggers jobs to pull data, to massage data, to do ETL steps, to produce Tableau extracts. It does a lot of stuff in there. I want to be able to see that. I want to be able to see what the runtimes look like, and I want to be able to see when it fails. Okay? So what did we do? We actually wrote a wrapper. So when a cron job kicks off for us, the first thing it does, it writes a little entry saying, hey, I'm going to kick off this job. I'm starting it at this time. When that job runs to completion, it writes a little entry that says, I just finished this job. It ended at this time. That's about it. Doesn't do much more than that. But because it's writing that into text files, right, we can then take that as an input, write some SQL on top of it, or within the system, and put a Tableau report on top of it. And this is what that looks like. This is a tiny fraction of our cron visualization for each day. We run somewhere around 5,000 jobs a day, give or take, just to give you some context, right? So you can see the bits where there's the size of the bar indicates how long the job ran for. The name over on the left is the business process that is running, which, by the way, is also, generally speaking, keyed to the JIRA ticket that was the original requesting ticket for the job, so we can trace it back. So you can see down at the bottom here, we've got just a ton of little teeny green blobs, right? Those are our just very simple production data extracts. They run very frequently, they're quick, super stable, relatively little can go wrong with them, and we do it a lot, right? You see up at the top, way bigger jobs, right? So the x-axis here is the amount of hours. So like one of those big orange blocks up at the top there, orange because they're taking longer, is probably an hour plus hour 30 runtime for a job, okay? Red means something failed. I haven't got a confirmed endpoint. So for example, the big red block over here, I can immediately go in, and I do this every day, I pull up, give me all of the list of the reds, right? That thing ran for like 3 hours and then died. Now, good news is you can see the green block following right after it, so it kind of caught itself up. But that would be a trigger for us to go and research, well, what happened? Why did it get stalled? What happened? Do we need to catch it up? Have we got any bad data anywhere in the system that we need to trace down, right? Like I said, we've got about 5,000 jobs a day. This is invaluable. I know with a click anything that has failed, and we can also, I mean, you can probably guess, red is fail, Orange is very long running, yellow is fairly long running, green is pretty short. Where do we focus our optimization? Orange first, yellow second, green last, right? So if someone comes to me and says, oh, we really ought to optimize this script from my engineering team, my first question is, well, conceptually, yes, but this thing runs in about 3 minutes and it never fails. So put that on the the bucket list. We'll get to it, sure. From a technical point of view, you're right, but we've got bigger problems first, right? The other thing, and I'm just jumping back slightly here, the other thing I found really, really valuable to do was we put some custom jobs in place that run, it's about every 10 minutes, all day, every day. And it's a little tiny Impala script and Spark script. Go out, pick up some data from a set data source, sort it, do some aggregates, nothing too complicated, then write it to disk, right? And we do the same thing. We log the start time, we log the end time of every instance. Data set never changes, nothing ever changes, right? Why would we bother to do that? Well, I can then report back on that runtime. It's like a heartbeat query. So then what I can do is I can plug that back into Tableau, and I get something like this, where the color coding indicates how long it took those heartbeat jobs to run, right? So horizontal on the bottom here is the date. Hour of day is at the y-axis there. Dark blue indicates this thing ran fast. Dark red or dark orange, I was careful for the colorblind people in the room if there are any. Hopefully you can see this. Dark orange, this was slow, right? So what it gives me is a longitudinal view of exactly the same query, how long it took it to run on average for each of the 6 instances in that hour. Why did we do that? This is by far and away the best indicator we have of what the end users are actually experiencing in terms of response times on reporting. There's nothing in Cloudera today, and if there's Cloudera folks in the room, I'm happy to talk about this, but there isn't, as a product manager, with my product manager hat on, there isn't anything in Cloudera today that you can look at that gives you this sort of simple, like, here's what your end users are going to experience in terms of Impala runtimes. This is the Impala one, not Spark, but we have the same thing for Spark. The obvious question is, why have we got a giant orange blob in there, right? What happened? So what was going on there, you can actually see as we went along, we were maxing out our second cluster buy. And what that, in particular on I/O, and one of the things that we did, don't do this, is we turned off the data rebalancing over the nodes. Bad decision, right? Well, tough decision. The problem was we were using so much of the I/O. For those of you that don't know, Hadoop stores data in replicas over different data nodes. So we have, any given file will be on 3 different data nodes. Naturally, as you write data, some nodes are going to end up with more data than others. That isn't a great idea because then you end up hitting some data nodes more than others, right? You end up with choke points. Rebalancing is an internal process that'll move the data around so it's evenly distributed between your data nodes, right? Very smart technology. The problem was we had so little I/O that we couldn't afford to do that data movement. Just sent ourselves into a death spiral because then our nodes got more and more unbalanced. Impala was taking longer and longer because you were getting these choke points, right, where the same data nodes were trying to service all kinds of different requests at the same time, slows everything to a crawl, right? So what happens, and you can see where we cleared it up, that's our new technology, that's our third cluster, where we rebalanced everything, redistributed the I/O compared to CPU capacity, right? And you can see with the odd little blip as we're doing big releases before Q4, we're pretty much back in the blue at this point, okay? So if I hadn't had this, I think it would have taken us probably 6 months more to try and figure out where we were getting to, and I would have had 6 months of major user dissatisfaction, right? With this in place, I literally walked into the tech team and said, we have a problem. And 1 slide later, there was no debate that we had a problem, we moved straight onto solution, right? If I hadn't had this, I know, even with a supportive tech team, it would have been months. Do we really have a problem? Can we tell where it's coming from? Are the users actually complaining? Yeah. Decision done. right? Cut months out. The thing with this, and the reason I'm telling you to do this early, is you don't need it until you need it. And the value is having the longitudinal, right? So I'm very glad that we did this in the early stages. Okay. And that's it. Those are the big things. There's a million other little things that we came across, but those are the ones I decided to highlight because I do know that if you don't fix those or deal with those issues, you're going to have a problem. So I went slightly over. Sorry, we have about 10 minutes for QA. I was aiming for 15. I think this mic is live. If you wouldn't mind coming up to the mic, that way I'm not trying to replicate it back and it'll get picked up for the audio feed as well.
So you mentioned your legacy architecture, but you didn't really get into the detail. So what happened with all of that?
Yeah, it was turned off. So we were on SQL Server. It was a standard relational database. We had SQL Server analysis services sitting on top of that. We had SSRS. We replaced everything.
And how big was that?
I've forgotten exactly. It was the biggest that you could get at the time.
No, I meant in terms of assets, like reports or... Because I'm imagining users in the beginning were starting to scream when you were starting to take that away from them. So how did you manage that transition is what I'm trying to get at.
That was carefully, I think, is the answer. So we did a gradual transition over time. So what we did is we looked at, as best as we could on SQL Server, we looked at what was making the major footprints. So what were the reports that were being used the most? And who is using them, right? You can do that via SQL Server admin tools, and most relational databases are something equivalent where you can figure out who's doing what. The first thing we did is I actually did a grid where this report is used X amount of times per month, I think I did it at. And then I pulled all of the users and stat ranked them by their position within the company. So if I had a report that was being used 5 times a month by my CEO, compared to something that was being run 15 times by a junior marketing analyst, I would give a higher rank to the report that the CEO was using, and we migrated that first, right? So effectively, the more executive exposure that a report got, the more it was kind of at the top of the company. We did those first, migrated those, it was kind of part of the POC phase, and then walked down the list. So it wasn't a hard cutover.
No, and that makes sense. I'm just imagining that even the transition work was a big amount of work and was a big expense as part of that transition.
It was substantial.
Yeah.
Yeah. I mean, you don't want to go into it lightly, but ultimately, I mean, like I said, we were in a position where there was no way we could buy a bigger machine. And Ebates is doing very well. We're growing very nicely. Sure. We couldn't handle the data we had. I mean, the projections for 2 years out were just like
you didn't have a choice. You just had to pull the Band-Aid off and go.
The only thing we could have chosen to do would be to silo the data onto multiple different single instances and then deal with recombining it. And we were like, my recommendation, I got the buy-in from the engineering and the exec team, that was a worse option than just kind of going all out and building the infrastructure that we really wanted.
I mean, we're in that same position. We're thinking about doing what you've done, but our legacy environment is complex and large, and we've got a lot of people who know it cold, and they've been with the company for years. And
it's not.
How do you pull that trigger, right?
You need high-level buy-in, and you've got to make the case. For us, it did help that the finances made perfect sense as well. We were, we hired consultants on short-term contracts initially. Actually, we ended up making them into FTEs, but we did the math and we said, well, look, this commodity hardware, even with the Cloudera licenses on top, because we can get most of it open source, is so much cheaper than trying to add these additional machines and then all the infrastructure we'd need to blend the data back. Honestly, the finances.
You can do a simple time to pay back and
Well, plus they can capitalize it.
Thank you.
Which they like. So the question was just a quick follow-up. How long was the transition? Overall, between POC to the point where we literally turned off the very last functionality was the best part of 2 years. But I would say that we'd actually migrated most of the critical stuff within a year. And then it took us another year to sort of do all the long tail stuff because it wasn't that critical. And at that point, we'd taken so much load off the old platform that we deliberately left some relatively light things going there until we had the time to get to them. So if we'd been aggressive, we could have done it in just over 12 months. Yeah.
Are you seeing any slow performance when you're connecting Tableau live connection to Hadoop? Or you're always going through at scale?
No, we have a lot of live SQL as well, a lot of live SQL. In fact, as a percentage of reports, probably more of our reports are on live SQL than at scale. It's just that the ones that are used the most are on at scale. You will see good or bad performance depending on how your data is architected and depending on how well your SQL's written. So, you know, kind of like any database, right? So if you've got reports that are basically joining 3 big tables and doing a select star, that thing's going to move like a snail.
Yeah,
if you optimize it, you can get better performance.
One more question. Are you using Hive driver or Impala driver from Tableau to SQL?
We use Impala.
Impala?
Yeah.
Right.
So we found Impala. We're starting to play with Spark SQL as well. My feeling on this, watching those communities develop, it still feels like a 3-horse race. Right now, we're using Impala because we think that for our use cases, Impala is the fastest. But you can Spark SQL is definitely faster in some scenarios, and Hive is still actually faster in some scenarios as well. So our long-term vision, now that we've sort of got through the major migration and we're into optimization and tuning, is we will use whatever SQL version is the fastest to execute that precise query.
Thank you.
Excuse me.
So before you went to at scale, what other vendors did you take a look at and relative pluses, minuses?
We didn't. We didn't. Like I said, I don't want to go into at scale too much because there is another program session to really talk about the functionality. At scale is doing something that I don't actually think there is a competitor in the marketplace today that is doing the same thing, which is it doesn't require the upstream commitment on the visualization tool, and it doesn't require you to move the data, right? Most of the other functional platforms that'll try and do what at scale does today, they want the data in the cloud, or you're locked into a proprietary visualization product at the endpoint. I mean, some of you may know of smaller products out there that are coming up and trying to do the same thing, but certainly at the point where we were looking at it, no one really on the radar that was doing the same thing that met those criteria. We did not want to have to rehost everything in the cloud, right? We've got all of this storage, we've got a lot of CPU and memory, why would we duplicate it all into the cloud and have to pay for that? And we didn't want to be locked into a proprietary visualization software. You know, we want to be able to back whichever is the best at the time.
Because you don't want to talk about at scale, I am familiar with how it's more of a hybrid question since you have somewhat of a hybrid reporting environment. I know at scale does a lot of distinct count estimates.
Yeah.
And considering you're also reporting directly from denormalized tables, do you find governance around distinct counts? Like, are you reporting 2 different sets of numbers because one is an estimate and one is a raw count? And how do you do, I mean, and even just ETL logic or calculation logic being in 2 different places, how do you resolve that from a governance perspective?
We dodged it because
You dodged it?
Yeah. We don't really use the hyperlog estimates with that scale very much.
Raw. Okay.
We use the raw because what we found is that by the time we put all of this in Parquet and we did good ETL up front, our average report times on at scale, even if you're going in cold, so you're not using any of the aggregation technology, is probably less than a minute. And by the time they've actually seen a query once, we're getting like sub 2-second query times on true distinct counts.
Do you find that you have logic in 2 places in general, or just you have it in one? And where is that?
In the ETL process.
And just one other quick question. When you said you took like your Starflake, you could call it.
Starflake.
Yeah, Starflake, and moved it over. And then do you do denormalized tables that pull out of your data warehouse into to denormalized tables, or are you skipping the Starflake? Do you understand my question?
So we replicate, I mean, in the sense that the production systems have effectively Starflake. Starflake? Now you've got me doing it. Snowflake schemas, right? So we'll replicate whatever the data structure for the production table is, because we just pull them in raw as is, right? So there are definitely some situations, niche use cases, or just reports that aren't used as much, where we'll just query directly off the data lake. In which case we're dealing with that star schema, because it's typically star, not Snowflake, because it's production systems, and we'll just use SQL there. So that's our data lake. By the time we move into what we call our DW layer, we'll have denormalized everything.
Okay, so your DW layer is mostly just denormalized tables?
Almost exclusively. There are one or two, they're not exactly slow changing dimensions, medium changing dimensions, that just didn't make sense. We would have had to do too many updates. But I think that's like 3 tables or something.
Cool.
I mean, very small.
Okay, thanks.
Sure thing. We got time for one more question. We're done, people. Sorry. I am around. There's the at-scale talk tomorrow morning where I'll be there. That'll be relatively interactive. And, hit me up on, Thanks, everyone.